You would not survive the first 3 miles, not the molten core, not the crushing pressure at the middle of the planet. Just the first 3 miles straight down would already be enough to kill you, and what happens after that is even stranger than anything Jules Verne ever imagined. This is what would really happen if you tried to travel to the center of the Earth. Start with the ground beneath your feet right now, because most people have no real sense of how thin it actually is. The solid outer layer you are standing on, called the crust, is remarkably thin compared to the rest of the planet, ranging from about 3 miles thick under the deep ocean floor to around 25 miles thick beneath the continents. In proportion to Earth's overall size, this means you are standing on a layer roughly as thin as the skin of an apple compared to the whole fruit, and yet this razor-thin shell is the only part of the planet humans have ever actually drilled into. If you began digging straight down, you would immediately run into a problem that has stopped every real attempt humans have ever made. The deepest hole ever drilled by humans, the Kola Super Deep borehole in Russia, only reached about 7.5 miles down after nearly 2 decades of continuous drilling, and even that comparatively shallow depth pushed the limits of engineering, because temperatures at the bottom of that hole reached a scorching 356 degrees Fahrenheit, far hotter than engineers originally expected, and hot enough that the rock itself became more plastic and difficult to drill through than solid stone. Now imagine you somehow bypassed all of these engineering limitations and continued straight down past the crust into the next major layer, called the mantle. This is where your journey would become genuinely deadly almost immediately. The mantle makes up the largest portion of Earth's interior by volume, stretching down roughly 1,800 miles, and while it is technically solid rock rather than liquid, it behaves almost like an extremely slow-moving, thick liquid over long periods of time due to intense heat and pressure, similar to how solid glass can very gradually flow over the course of centuries. Temperatures within the mantle range from around 1,000 degrees Fahrenheit near the top to over 7,000 degrees Fahrenheit near the bottom, more than hot enough to instantly vaporize any human body, any known spacecraft material, or literally any substance currently used in engineering on Earth's surface today. Pressure would become just as deadly as heat during this stage of your descent. As you moved deeper into the mantle, the crushing weight of the rock above you would create pressures reaching millions of times greater than what you experience standing on the surface right now, pressure intense enough to compress even the toughest materials into entirely different physical states, forcing common minerals to rearrange their atomic structure into denser forms that do not naturally exist anywhere near Earth's surface. Continue falling deeper, and you would eventually reach the outer core, a layer made primarily of liquid iron and nickel located roughly 1,800 to 3,200 miles beneath the surface. This layer is genuinely liquid, not solid rock behaving like liquid, but actual molten metal swirling and churning constantly. This churning motion is not just a curiosity. It is one of the most important processes happening anywhere inside the entire planet, because the movement of this liquid metal is what generates Earth's magnetic field through a process called the geodynamo effect, the very same protective magnetic shield that currently blocks harmful solar radiation and cosmic rays from stripping away Earth's atmosphere. Temperatures within the outer core reach an almost incomprehensible 9,000 degrees Fahrenheit, roughly as hot as the surface of the sun itself, and any theoretical vehicle capable of surviving long enough to reach this layer would need to withstand not only that extreme heat, but pressures more than 1 million times greater than what exists at sea level on Earth's surface. Finally, at the very center of the planet, roughly 3,200 to 3,900 miles beneath your feet, lies the inner core, a solid sphere made primarily of iron and nickel roughly the size of the moon. Despite reaching temperatures of approximately 10,400 degrees Fahrenheit, hotter than the outer core itself, This layer remains solid rather than liquid, and this happens for a genuinely fascinating reason. The pressure at the center of the Earth is so extreme, estimated at more than 3.5 million times the pressure you experience at sea level, that it physically forces iron atoms to remain locked into a solid structure despite the intense heat that would normally melt them completely under any less extreme conditions found anywhere else in the solar system. If you somehow reached this exact point, the literal center of the planet, something genuinely strange would happen to gravity itself. Since you would be surrounded by an equal amount of Earth's mass pulling on you from every single direction simultaneously, gravitational forces would technically cancel each other out, leaving you experiencing something very close to true weightlessness, floating at the exact core of an entire planet, a bizarre and fascinating detail that most people never consider when imagining a journey like this. Realistically, no version of current or foreseeable human technology could ever survive a real journey to Earth's center, since the combination of extreme heat, crushing pressure, and molten and solid metal layers make this journey scientifically impossible using any materials currently known to exist. Yet exploring exactly what lies beneath your feet reveals just how violent, dynamic, and genuinely alien the inside of your own planet actually is. If this one blew your mind, make sure you hit subscribe, drop a like, and leave a comment telling this channel where it should dig next, because a brand new episode drops every single day right here. Tomorrow, get ready to look up instead of down, because this channel is exploring what would actually happen if you tried to walk on the surface of Jupiter, and the answer is nothing like what you'd expect. Come back for that one.